Alright, today is all about different types of river valleys and also flooding. When we look at rivers, the river valley usually falls into one of two categories. It's either going to be a very steep-sided V-shaped valley or a more broad and gentle U-shaped valley. A narrow V-shaped valley is cut through downcutting. So that's when water is moving fast, usually somewhere higher in elevation up in the mountains, and that fast-moving water just wants to get down to base level. And the fastest way to get to base level is to cut straight downward. That produces these really tall, steep valley walls because the river just has one focus, to get down in elevation towards base level. Wide valleys are made through meandering and this side-to-side erosion. It produces things like floodplains. Within a floodplain and these meandering rivers, we can have cut banks, point bars, and oxbow lakes. When a river is meandering, the fastest moving water is always on the outside of the turn, outside of the bank. And that fastest moving water causes erosion on the outside of that meandering river. Since there's erosion, we call that a cut bank. It's cutting away at the bank of the river. On the inside of the river, water is moving slower, the inside of the turn. And since it's moving slower, this is where deposition can take place, and it leaves behind maybe sand. And this produces a point bar, kind of similar to like a sandbar you might see in Lake Michigan, where sediment is being deposited. That's a point bar. And every so often, cut banks can erode and connect together. When this happens, we kind of make a shortcut for the river, and that produces an oxbow lake. It's this horseshoe-shaped lake that eventually, after the shortcuts produce, water doesn't flow through the oxbow lake anymore. This produces deposition, which cuts off that lake from the rest of the river, and now we have this really cool shaped lake. When we talk about flooding, there's really kind of two different types of floods. When we just say a flood, those most of the time form kind of slowly over a long period of time. Maybe we have springtime snowmelt that adds a lot of water, or maybe some light rain over many days could add water to a stream and cause flooding. So most of the time, flooding is not an instantaneous event. It's over a long period of time. But there are special types of floods called flash floods that happen in just a moment. There's a couple special requirements to get a flash flood. Like you need topography, so I mean like steep canyon walls. You need really hard surface, so no soil, like bare rocks on the surface. And you need really intense rain over a short period of time. If you have all of these things combined, you have the potential for a flash flood, where water moves over the surface of these hard rocks straight into the lowest area, these canyons. And they can fill up very quickly with water. And that would be a flash flood. There are several different ways that we can control flooding. One of them is through artificial levees. We talked about the good side and the bad side of levees in a previous lecture. One of the good things about a levee is that it means flooding happens less often. You build up these man-made embankments on either side of a river, and then the river channel can hold more water before it floods onto the floodplain. So that's definitely a good thing. One of the downsides with levees, the natural levees, is that once it floods, the floodplain holds that water. It stays on the floodplain, trapped by the levee, and it can't run back into the river. So our artificial levees that are man-made, they fix this problem. They actually have pipes going through these levees and pumps that if it does flood, the water can be pumped from the floodplain back into the river. And I think the coolest thing about this is that we actually have examples of this happening right here in Hudsonville. If you know AAA Turf, the muck fields, right by 36, right by the school here, and if you drive by there every day like I do on my way to school and home, you might notice that sometimes there's water pouring through these PVC pipes from where they grow the grass to this little river. And that right there is an artificial levee. Another way to control flooding is through dams, and more specifically flood control dams. So these are dams that aren't across the river, but maybe they're just in an area where there tends to be a flood. Okay? And this dam, what it does is during heavy rain or lots of snowmelt, it will kind of close off the dam and control the amount of water that's allowed downstream, and all the extra water is held in a reservoir behind the dam. And then over maybe days or weeks, all of that collected reservoir water is allowed to slowly travel down the river instead of flooding it all at one time. And again, this is really cool. There's one of these in Hudsonville too. If you know kind of the north side of Hudsonville, Port Sheldon, between 48th and 40th, on the north side of the road, there is a flood control dam. There's a nice little walkway, a grassy area that goes over top of it. It's part of a running path. But if you show up there after several days of rain, on one side of that nice walking path, you're going to see a reservoir that wasn't there just days before. And the last way we can try to control some flooding is really just limiting development. I mean, let's stop paving everything. If you think about parking lots or the roof of the building or just all of these paved areas, they don't allow any infiltration of rainwater. So that means when it rains very hard, water travels over top of the roof, travels across the parking lots, and it can flow very quickly into river channels. And that might cause flooding. If we didn't have so much pavement everywhere, water would very slowly soak into the ground and very slowly travel to the rivers through groundwater, and that doesn't produce flooding. And the last thing for today are drainage basins. A drainage basin is the land area that contributes water to a river. So we can look at a map and you can actually encircle these drainage basins, and when you're looking at a map and you've made that circle, every drop of rainwater that falls within that circle all travels either on the surface or through groundwater to the same exact river. And that's what we mean when we say a land area, a chunk of Earth's surface that contributes or adds water to a river. These drainage basins are separated by what we call divides. A divide is normally some sort of higher elevation that separates two drainage basins. And an example just might be if water falls on one side of a hill, that water would flow to one specific river. But if water were to fall on the other side of that hill, it would flow to a different river altogether. And there's a really special type of divide called the continental divide. It actually slices our continent in half. And the really high elevation we're talking about that is the continental divide, it's the Rocky Mountains. So anything that is on the east side of the Rocky Mountains eventually will flow to, any rainwater, any rivers will flow to the Gulf of Mexico or to the Atlantic Ocean. Anything that falls onto the west side of the Rocky Mountains or this continental divide will eventually flow into the Pacific Ocean. That's all we have for today. Please make sure you're filling in your notes and you're asking questions when they come up. Thanks.